the material in the Hadoop analyst exam, right?
Mm-hmm.
So I have one set up for Spark. That's the one that I sent you. Here's the one that we're on. It's just a CentOS 7 box.
Oh, I don't think you sent me yet.
I added you. I gave you permission to have read access to the Spark Dev VM. It's on the Google Drive. I gave access to your
Oh, let me
email.
double check. Yes.
Yeah, you don't need it right now anyway, so it's not
Okay.
a big deal. All
Mm-hmm.
right.
Okay.
So you're familiar with like the command line Linux and stuff like that?
Mm-hmm. Yes.
Okay, so this might be a little boring, but I just want to, because I have to study this stuff too, so this is like my review as well,
Mm-hmm. Yeah,
because
that's all right. That's all
you
right.
need to know this stuff for the exam anyway, like
Mm-hmm. Yes.
how it applies to HDFS. Like,
Mm-hmm.
okay, so I'll just start speaking. I don't have my stuff in the slides yet, but I can just speak
Mm-hmm.
to stuff.
Mm-hmm.
All right, so let's get a browser window open. Okay, so Hadoop, what is it? It's an ecosystem that provides scalable and fault-tolerant data storage and processing, right?
Mm-hmm.
It uses clusters for storage and compute, and clusters are just groups of servers. With Hadoop software installed. So the scalability aspect, how is it scalable? You know, I should just write this down as I go.
Mm-hmm.
You can just kind of see. Scalable.
Mm-hmm.
How is it scalable? Um, Storage and compute can be scaled out through the addition of nodes.
Mm-hmm.
That's it. You can use cheap commodity hardware for that. So now, how is it fault tolerant? It's fault tolerant because of data redundancy, right?
Mm-hmm. Yes.
You can set a replication factor. So like every piece of data that you have can be replicated like 3 times. I believe that's the best practice. Replication factor equals 3. So you can have 3 copies of the data.
Mm-hmm.
So if you lose it somewhere, you can get it from a backup source. Also, fault tolerance is not just with the availability of the data, but with the availability of processing resources, because data processing is broken up into tasks, right, and run in parallel.
Mm-hmm.
So this is done automatically with Hive, like it's abstracted from the user. But now with the addition of Spark, as you may already know, you'll have the ability to, you know, control the different parameters of a job. Because like when you use Hive, it's basically providing an abstraction layer for you. So you can use SQL, and then that SQL gets converted to MapReduce, and then MapReduce with Yarn can then, you know, divvy up the job into tasks and run them. And if a particular node fails, the task on that node would just be rerun on another node.
Yes.
If a node fails, the associated task is rerun on another node.
Mm-hmm.
So how is data stored? Like by default for Hadoop, you know?
In Yarn, right?
And where? Sorry?
It's Hadoop is stored in the like Yarn is the storage system, and the Hadoop is stored in HDFS, right?
So Yarn is not the storage system. That's the resource management
Yes.
aspect. So, but
But
you're right about HDFS.
Mhm.
Yeah, go on.
Yes, yeah, yeah. So Yarn is like Zookeeper, where they like for task scheduling, and for HDFS is like the storage system of file in Hadoop. That what I understand.
Yep, you got it. So Yarn. I'm not too familiar with, I know Yarn is just yet another resource manager. So that's what, it acts like the brain in terms of divvying up how jobs are going to be executed, like what node gets what task, and then HDFS is just Hadoop distributed file system. It works just like a regular file system, sort of. There are some nuances which we'll go over in a demo later. So do you know, let's go over. So HDFS, let's just build on that a bit more. It's one of multiple storage options for Hadoop. You can use Hadoop on different storage systems like AWS S3, right?
Yes.
You can use, use that in conjunction with, well, you can build your own cluster in AWS with EMR, but you can also run queries directly against S3. I believe you can use Impala. You can put Impala on top of S3, but AWS offers its own native querying engine too for data in S3, and that would be Amazon Athena.
Yes.
So have you ever used Athena?
No. I know the theory, but I haven't actually used it. Just S3 when I do the glue, S3 and RDS.
Okay. So Impala can be executed against data in S3. So another thing too is, with Impala, anytime you change the schema of an existing table or you create a new table, you now have to invalidate the metadata in the meta store because that gets cached. That's part of the reason why Impala is so fast, because it has all of the structure and location of the data already cached. But the downside is that you just have to invalidate the metadata whenever you make changes. So that's, I'm just going to mention, I just started using Athena at work. That's one of the benefits of Athena. It actually combines the query with, like the query for data, with the query to the metastore. Of course, in AWS, it's not called a metastore, it's called a data catalog. So that's all built into the same query, and it's lightning fast. And you don't have to worry about like invalidating metadata or anything like that.
Yes. So are you using like AWS Glue to do the task for distributing?
Yes. Yeah, Glue, it by itself is just, its main purpose is for data ingestion for ETL use cases. But you can also use it, to take the place of Spark on AWS. And it also has a subcomponent called the data catalog. And that's just like a meta store. It just contains the metadata about your tables, your data. Like it'll have the location, it'll have runtime parameters, it'll have like the data formats, things like that. So, so HDFS, what else? We know that it can interface with other tools in the Hadoop ecosystem, right? Like, what are some tools that you can use with HDFS? Like Hive, we know that.
Yes,
What else?
Hive, Impala, Uzi for the task scheduling, right? Pick, I haven't used it, but I heard like there's option for Pick.
Okay.
I think one of my coworker was introduced about that. Let me see. There's another one of the animal that let me see what is the name for it. It's really weird. It's one of the animal that he said is was using to converting the file. I think. Let me just quickly double check on that.
have my dinner here too. I just ordered. I didn't feel like driving to Vietnamese town, Little Saigon. That's what it's called.
Mm-hmm.
I just went to a Chinese restaurant up the street and got myself a lobster, two lobsters.
Wow, that's fancy. You feel fancy
It's
tonight.
the main reason I did it is because I didn't want to lose my parking spot.
Oh, Apache kudu. Let me see.
Uh, what's a kudu? Is that an animal?
Yeah, they are all anymore. Let me see what is. I just heard him mention about it. I didn't.
I think you mentioned it to me too. Isn't that um, the system that's going to automatically take Python code as input and produce PySpark code as output? Was that what it was?
Maybe I
Or
forgot.
maybe I'm confusing it with something else.
Here, let me send you the link. Just a minute.
It's a word animal.
Yeah, too many animals. Like a
Yeah.
zoo here.
Okay. No, I'm thinking of something else. Um, Python to
Oh,
PySpark project.
I think the one that I told you is Koalas.
Yep. There we go. Thank you. That was it.
But this one is. Let me see what this is.
Looks like it's a columnar data storage system.
Oh,
I'll have to look into that more. Maybe
yeah.
there's a use case for it.
No idea what is it. I'll ask my coworker next time. What
It
is
looks like it's a cluster that stores tables that look just like tables in a relational format. I don't know. That's just from what I read off the.
Yes, probably is.
Okay. So now,
Oh, and one last thing in the stock of Cloudera, I think Nifi to yeah Nifi to access the data as task scheduling and pipeline. NiFi, I think I'm not sure it's pronounced NiFi or Nifi.
uh, I see. I'm only vaguely familiar with that. I haven't had a need to use that at work for task scheduling.
You don't need to use, so it's pretty much replaced NiFi. So yeah, it's only like the issue with the on-premise one where you have to like manually do a lot of things, then it's useful to use a NiFi or Airflow, but Glue replaced both of them. So
I see. All right. So we can access HDFS through the CLI. We'll go through that later. Um, so how does HDFS compare to a regular file system, Linux file system?
it's distributed, right?
Yes. What else?
Oh, that's all I
How,
know.
how are they similar? You know, they
Oh,
use.
yeah, I don't know.
Okay. So one of them, they have paths and
Yeah,
directories.
yes.
And differences, this one's very important.
Mm-hmm.
There is no concept of a current working directory. You have to qualify everything.
Mm.
You can't like change into a directory and be in that directory. It doesn't work like that in HDFS. And then, you know, like SCP, SFTP, you know, like the put command and stuff like that. Like if you're going from like a Windows file system to Linux,
Mm-hmm.
it's the same concept here with HDFS if you're trying to move a file from the Linux file system to the distributed HDFS file system.
Mm-hmm. Oh, yeah,
So
that's
since it's distributed, if you have many different like edge nodes, like client facing servers, you can just access any one of them. As long as HDFS, it's the underlying Hadoop file system for all of them. You'll be
mm-hmm.
accessing the same HDFS, no matter which one you
Mm-hmm.
log into.
Mm-hmm. Yeah.
Okay, let's take a architecture of HDFS. So it uses a name node, right? Hadoop uses a name node, which is just a master, and a set of data nodes, which are just our workers. So the name node, all that does is name node, that's going to monitor the data nodes. And then the data node is just going to read and write data. That's all they do. They just work. And then, like earlier, yarn, that's just used for yarn, is used for workload management. Now we get into data processing. Programmer tools. So with Hadoop, you can use MapReduce and Spark for data processing. And developers, we can write custom code in MR or Spark using the APIs, right? MR, I believe that's like Java focused, but Spark, it has APIs for R and Python, PySpark or Spark Lear. And then MapReduce, we know that's our original data execution framework, Java based. And then Spark, new data execution framework, more performant due to in-memory processing, right? And now we have analyst tools too. So we have Hive that basically with Hive you can queries written in Hive get converted to MR or Spark jobs, depending on what you set the execution engine to. By default, it's Hive. It's MapReduce. Like, that, right? Like, do you use Hue at work?
Yes, I do.
Okay, so hold on, maybe I can show you right now. I don't even know what the password is, whatever, hopefully it lets me. I don't think I have Spark installed here, but I just wanted to show you where you could make that change. So you write Hive queries through Hue, right?
Yes.
Okay, so if you switch over to the Hive editor, forgive me if you already know this, but I'm just going through it in case you don't. Go to the little year here, settings, and then you just do Hive execution engine and Spark. Now it'll convert your job to Spark and it'll run much faster.
Oh, I didn't know this. That's awesome.
Nice. So you learned something.
So I can write Spark on that.
No, you would use Hive QL, but this just tells you what it will get converted to. By default, it's MapReduce.
Oh, that's awesome. I'll try it next time. It'll work.
Yeah. So now, but it's slow still, much slower because than Impala, because it has to, just by the architecture of it, it has to first query the metastore every single time to see where the data even lives and how it looks like, its structure. So next up, and then Impala, right? So you can do a lot of stuff with this. Like if your job uses request pools, you can just do like the request pool and then whatever it is, Jane's team, Is they usually pre-configured with memory.
Can you talk more a little bit about request pool method?
Request pool. So with Impala, I mean with Hadoop in general, like for
Mm-hmm.
Impala, if you're using like a shared environment, you can set up
Mm-hmm.
pools to divvy up the resources. So like if there's like two different groups, you can give them each 50% of the resources at one
Mm-hmm.
time. But they would have to specify the request pool. You can name the pool Jane's team, and then there's another one which is Mike or Smith's team, and then we each have 50%. You can get flexible with it too. Like if there's just idle CPU, then it'll just give it all to, you know, whoever requested first. But this
I
is just a way to make sure like everyone plays nice with each other.
Mm-hmm. So can people like multiple people use the same request pool?
Yes.
Oh, let me check this.
That's how it should work, because you don't want to like be setting it to each individual person. It's just kind of like a grouping resources by like different
Mm-hmm.
teams or whatever.
Yeah, I see.
So now going back here,
Mm-hmm.
analyst tool. So basically when you write a Hive query, it gets converted in the back end to either MapReduce or Spark code. So now, what else? HiveQL is, it's ANSI compliant with some extensions. That's how all SQL works, basically. Any questions on that? Huh?
No, no, I'm good. I'm good.
Okay. It's a little hard to hear you.
Oh, let me move my microphone closer.
You
Hear me
said
now?
no, right?
Hello? Can
Yeah,
you
I
hear?
can hear you now. Yep.
Yeah, yeah. I'm good. I'm good.
Okay.
I move.
So Impala is very similar to HiveQL. It's also ANSI compliant with some extensions. Like there are some differences. Like one thing I've noticed throughout my career is when you are setting an alias, like select, like let's say we're subquerying, creating a subquery.
Mm-hmm.
Um, like select all from db.table.
Mm-hmm.
You can alias that. And then you don't need the as, but I'll just do it for demonstrative purposes, as subquery one. So Impala will actually accept this, but Hive, Spark, it only, since it integrates with Hive, like it's compatible with Hive, you need to actually convert any Impala query that you write into HiveQL in order for it to be run in Spark using Spark SQL.
Mm-hmm.
But one thing that got me in the past that wasted a lot of my time is Impala accepts this, but Hive, you have to qualify it, like put it in encapsulated in quotes. But actually, this will work in Hive now, in addition to Impala. But actually, best practice is to use ticks.
Oh.
Very important, because especially if you're like very creative with your words, like let's say you just make it into role or df, that might actually be a reserved word. Or maybe it's not a reserved word now, but it might be in the future. So all of a sudden you have some code, like, in a pipeline for production, and then you guys upgrade everything, and then all of a sudden the data pipeline breaks because
Mm-hmm.
of a syntax error, and it's because something that you originally just had as df became a reserved word. So always do this.
I see. So, okay, I see. Yes. Yes, I got it.
Okay. So, and it's like 10 times faster at least.
Mm-hmm.
And the reason for that is that it runs directly against the data. it runs directly against the data. And it doesn't have to query the meta store every time. Meta store data gets cached. Okay.
Yes.
What else? What else do we have for tools? Other tools? We have Scoop. You know Scoop, right?
Oh yes, Scoop.
What is Scoop?
I didn't use it, but I saw it in the stack.
What's it used for?
Uh, for query.
For queries? What kind of
Yes.
queries?
Oh, I didn't know. It's there, but then I didn't use it, so I have no idea.
Okay. It is used for importing and exporting data to and from RDBMS to
Oh,
and from RDBMS to Hadoop. That's all it's for.
oh, okay.
And then now I'm going to show you a little bit about the command line, okay?
Yes, sure.
So let's open up a terminal. So here I am, home training on my system, right? Localhost.
Mm-hmm.
And then we have HDFS, DFS. Have you ever accessed HDFS from the command line?
No, I don't have the allowance to because yeah, I don't think I have the allowance to.
Okay, so it works kind of like the regular bash,
Mm-hmm.
but you have to precede everything with HDFS, DFS, and then
Mm-hmm.
you do ls. And remember, there's no current working directory.
Mm-hmm.
So if you don't give it an argument, by default, it will go to your user directory. So this is my user directory.
Mm-hmm.
So now I give it an argument. What does this mean?
I cannot see. Is it a dash?
A forward slash.
Forward slash? Yes. Oh, I don't know.
So this just takes me to the root directory
Oh.
of HDFS.
Mm-hmm.
So you see we have var, user, temp, and
Mm-hmm.
then just some other stuff. So
Yes.
if we want to get to user, go to user, right?
Mm-hmm.
So what is this telling me right here? What does that mean
You go into user?
in the root directory,
Root
right?
directory. Yes.
Okay, so there we go. But I'm not actually going there. I'm just listening because remember, you can't change directories. There's no concept of a current working directory in HDFS.
Mm-hmm.
So you always
Mm-hmm.
have to qualify like that.
Mm-hmm.
So now my user account is training. So as you can see, we're going to have the same file as here because this is the default directory, which is your user, and I am training.
Yes.
Does that make sense?
Yes.
Okay, so now back to this directory. Let's make a file.
Mm-hmm. Oh.
Ah, bloody hell. Okay, touch, let's just call it Jane data.csv, right?
Mm-hmm. Yes.
It's here, ll grep Jane. Okay, so now we want to put that into HDFS. So how would we do that, given what I told you so far?
Oh, so I would put it like.
Let me give you control. Can I give you control in this?
Yeah, yeah, sure. So now I have the file. Oh,
How do
so
I give you control?
I think you will option. Let me request remote control.
Okay, go ahead. Move that file into HDFS.
So it's not in HDFS?
No, because remember, this is just a regular file system.
Oh, okay.
Actually, let me make it a little simpler because there's a lot of crap over there. So let's make dir test, and then we're gonna move that file into test. And then we're going to move ourselves into test. So pwd test, here's the files. So move that into HDFS.
Oh, it doesn't appear. It doesn't appear. I clicking, it doesn't type in.
Try it again.
Yeah, it doesn't. Maybe
Ah,
because
maybe
it's
VM.
VM, yes.
Ah, bloody hell. Yeah, he's
That's
going to
all
make
right.
things.
So I was planning to like move the data to because in my work there's hang on, let me chat with you. I'm not sure if it's the right method. Let me chat with you. Okay, let me message you on the WhatsApp. Okay, so I was planning to move, change.
You're like fading in and out, like your microphone is going far away from your.
Hello, hello. Yes.
Yeah, I hear you, but you sound like very quiet.
Oh yeah, yeah. I was talking small.
No, no,
um,
no. Like it sounded like everything just got quiet. Like the
oh,
microphone like got further away.
that's strange. Okay, I'll buy a new microphone next time. Because the thing like if I don't use the original microphone in here, sometimes like when I'm when I yeah it's yeah it's weird. Okay, but anyway, motion data.cfp. So let's see. So if
See, it's low now.
oh can you
It's like, here's how it sounds to me. Hey, how's it going? My name is, and then I went there, and then I went. You see the change in volume?
that's so strange. It's a safe spot. Maybe it's
Yeah,
just connection.
yeah, maybe. Fucking
Yeah.
UDP.
So name node, whatever,
Wait. Why? Are you sure you want to use MV? MV is moving intra file system. Remember that. That's
Oh,
intra.
yes. So copy, right? Let me, let
Looking
me.
around my browser.
Oh no no, your browser. I thought it
Yeah.
mine. Sorry, I was planning to Google. I was so embarrassing.
All
How
right.
to buy Google? Oh,
Still on
it's
my
your.
computer.
Okay. Okay. I'm not sure.
Now
I
you don't need Google for
Google.
this. I already told you everything you need to know. Like remember, we're moving this into Hadoop. So it's a
Mhm.
Hadoop utility we're going to be using. And remember, what is the thing that you have to have before every Hadoop command? A hint, it's two things. Remember, I executed it earlier. You can go back and refer to the command line and I'm sorry, you can't control it, but I'll show you what I did so far. History, right? Grep.
Mhm.
Can you see it here?
Let me see. Hadoop, please. Hadoop DFS.
Yes,
Oh, that's strange.
because it's a Hadoop utility. You have to
Mhm.
call it that way. If you try to use MV, you're going to be talking to Linux and not to Hadoop.
Oh, I see. Mm, that's strange.
So yeah, so
I
just
have a.
modify the command.
Oh, that's right. That's right. Yes, you are right. I remember now. Okay. Yeah. Yes, you are right. Hadoop DFS. So how do you move the file? Oh, wait. You are asking me that. So, so is it DFS? DF, right?
You don't need the dash there. You only do the dat. Yep, good.
Oh,
DFS.
okay. Not, not user.
DFS for distributed file system. HDFS, DFS.
Oh, I see.
And then remove the move Jane CSV. You want to start it with HDFS DFS to let the system know that you're talking to Hadoop. And then the next thing is your command. So that's not a command right now. What you have there, you're saying current directory name node user. You need the command next, preceded by a dash.
Mm.
So what's the command? Remember what I told you, like it's just like SFTP.
Please write it out loud.
HDFS.
Yes, yes.
Look, this will show you everything that you can do with HDFS right here. So it's
Oh,
one of
oh,
these.
CP, copy, right?
Well, you can, but do you want to copy it? You want to have the data on your local file system and your HDFS?
Oh no, no. Oh, we
Okay.
can move. Yes.
Well, remember, move is intra file system. You need something to cross over file systems. Think SFTP.
Oh, I see. SFTP. Get
Starts with a P.
put. Oh,
Yep.
oh. I need to review my command line. Put. Oh, okay. I see that. So HDFS, DFS, put gen data.csv and the folder, right?
Mm-hmm.
Mm-hmm. Yes.
Exactly. But remember, yeah. So remember, I think it was user
Mm-hmm.
training. Then I think we created a test folder.
Mm-hmm. Yes.
So now we can go ahead and check that folder to make sure it's there.
Mm-hmm. Yes.
There we go.
Mm-hmm.
I mean, nope, sorry. Did something wrong. User training. Test is not a directory. Okay. Yeah, I created the directory in the local file system and not in HDFS, so it didn't exist. So we're just gonna go ahead and create that now. So now we have the test directory set up, right? So
Mm-hmm.
training, and then you can, that's weird. Hold on. HDFS, DFS, make their user training tester, HDFS, DFS. So just take me to that folder, my home folder. Okay, tester. So now we're gonna move that there. Put chain data in tester. Now we can go ahead and check that now. I gotta qualify the whole thing. User training tester. There we go. You see it?
Yes.
Okay. So we got the data there.
Mm-hmm.
Now, what else can we do? And then we want to take the data back. All you would do for that, like, let's just move to another folder. I think put actually makes a copy anyway. It doesn't delete it. So let's delete it. So now we have nothing here, right? So just go back to that command. Get, and then we're getting chain data.csv.
Mm-hmm.
Now we look here, we got it.
Yes.
Okay. Make sense, everything?
Yes. Yes. It's good.
Now, I showed you the hard way. Now we can look at it the easy way. You go into Hue. Have you ever messed with these functions before?
Oh, in where? Yes, definitely.
Okay. So it's the file system we just looked at. You
Yes,
can do it from the GUI. So that's
yes.
it. So it might be easier to do it this
Yeah,
way.
yeah. That's what I do at work. I just use this, so I don't know about command line.
Yeah,
Yeah, I see. Yes. Yeah, I've got it. Thank you, Smith.
you're welcome. So moving on now. Um, let's talk about Hive and Impala some more. So do Hive Impala. This was just overview. Let's start talking about Hive first. We know that it uses Hive QL, which is just like SQL. We know that it converts queries into jobs to be run on the cluster. And we know that it removes the need to write custom MapReduce or Spark jobs. You don't have to do it. So that's what it's for. It's for non-programmers.
Hey, if I move my computer like this, can you hear me clear?
Yeah, you sound good. You haven't faded out for a while.
Oh, okay, that's good.
Sorry, meat and lobster at the same time.
Wow, that's so awesome. You should pour yourself some red wine too, you know.
You know what? That's not a bad idea.
Yeah, do it. You see?
I think I will. Like when I moved in here, the building gave me a bottle of red wine. I never opened it, and I've been living here 3 years.
Wow. Now it's very well aged. You see?
Yeah. So what do we know about Impala? Can you tell me
Uh,
about Impala?
it used Impala QL. I don't know.
Yeah,
It's basically the same though.
they have different extensions, and Hive is actually more flexible
Oh, I
in
didn't
terms
know
of
that.
dealing with complex data types. Like,
Oh,
have you ever
yes.
had to deal with those yet? Like JSONs and
Yes.
okay.
Oh, yeah, I was about to talk about the data hive in Hive, that there are several ones that different from the normal SQL. I was reading about it the other day.
You know what else I like about Hive too? It gives you the ability to sort arrays, sort complex data types. So if you have
Oh,
like, let's say you have a data structure like this, just a field. One of them has this in it. It has Smith 34 male, and then you have another record 34 male Smith. Now, if you do like a some operation aggregate function on it, these are going to be seen as two different things. So there is a function that Hive has, but Impala doesn't have right now. It's called a sort array. So you would just pass, if this isn't a variable called x, you just pass x into it first, and then you do your aggregate function. So Impala doesn't support that, but Hive does.
oh, I see. I didn't know that.
So now, so you said it can query data, right? You know, in HDFS and S3 starters. Does it need to convert queries?
Yes.
No.
No? Oh, okay.
That's what makes it faster because it doesn't have an underlying execution engine like MapReduce or Spark. It runs directly on the data. There's no middleman.
Oh, I didn't know that.
Removes the need to convert queries into jobs. That's why Hive and Spark take much longer.
I see.
Queries are run directly on the cluster.
Oh, I see.
Which is faster, Impala or Hive?
Impala.
Why?
Oh, well, it catch metadata It doesn't write custom MR or Spark. Like it run directly against the data.
Correct. Let's talk about the benefits of both. What are the benefits of both? Why is Hive and Impala so good versus like Spark and MapReduce?
It's easy to use, right? It uses standard SQL, so you don't need to like know how to Spark, and you don't need to use API like using Python or.
You don't need to be a programmer, essentially.
Yes. Yeah.
What else can you do with them?
You can scheduling jobs with just SQL script using Uzi, right?
Mm-hmm. What's a key thing you can do? Like when you want to like do like visualizations and stuff.
Extract data.
Yeah, like basically it can integrate with BI tools like
Yes.
Tableau.
Oh, yes.
Let's talk about tables. Tables have two components in Hadoop. We talked about these many times already. What are the two components of metadata? I mean, sorry. What are two components of tables in Hadoop? I said one.
Let me see. Two components.
Talked about this a lot and I just let it slip a second ago.
Oh, metadata.
Yeah.
Okay. Oh, okay.
So what is metadata?
Oh, it's just a catches of a schema.
What else besides schema?
Uh,
Schema will give us the structure of the data.
mhm. Oh, we need data type.
What else do we need about? What else do we need to know?
Data
That's in the
type.
schema.
Oh, okay. Don't know.
What else do we need? We need to know where it is.
Yes. Metadata and location. Yes.
And then what else? What's another thing? Wait. What do we have to do to the metadata if we create a new table or add a new field?
We need to refresh it.
Yes, invalidate it. Get rid of the data in the cache.
Yes.
So what's another component of a table in Hadoop? Don't overthink it.
Row and columns. I don't know.
Yeah, technically, the data.
Yes,
Data itself.
Yes, data. That is the second component. Oh, okay. Okay.
The actual data in a table. How is this data represented in HDFS?
You see, it's in the packet file, right? Packet format.
If you choose that as your data format, yeah. But how is it generally stored in HDFS?
Well, it's stored distributed in it's stored distributed into like fragments of the a fragment of the files. I'm not sure.
Yeah, I don't think I'm asking. Well, it's kind of like specific. I'm not asking the right question, but basically, they're stored as files. You know, in a directory. Each directory represents a table. Right?
Yes.
Let me see if this is.
Yeah, it's in. Oh, what is it?
It's not a good example, but basically we would have like a folder for the table. and then we'd have a whole bunch of files inside that make up the table. And then if you have folders already in a folder for a table, what do those folders represent? Why would we have subdirectories?
For example, when I use glue, for example, when I write our file, it's in like different fragment because it's split up, and then they all put in the same table that name the table. Is that what you ask? Is it different?
My question is, do subdirectories represent here? So we already know that the data is stored as files and the table is represented as a folder. So what happens when you have a subdirectory in one of these table folders? What does the subdirectory represent?
Multiple tables?
No, because we just have one table.
Oh.
So we'll have something like this, right? Table, and then we have file part 1, file part 2.
Oh.
But what happens if instead we have like something like this, subdir, and then inside a subdir, file part 1, file part 2. What does that mean?
Different checkpoint? Like, I don't know. Yes. So
Partitions.
partition, yes.
What's the benefit of a partition?
Oh, file is partitioned into different nodes because it keeps the record of multiple tabs.
No, that's replication factor.
Oh, so if, for example, if you suddenly one node die, then you don't lose all of your data, right?
No, that's replication factor.
Oh.
Why do we need partitioning? What is the benefit?
Actually, no. Yeah. Let me think. So partitioning. So basically, all I know about partitioning is that like when I write on glue, it's split into like multiple files, and I have to be partitioning it. And I have never thought reason why they do that. Yeah, I don't know that.
So partitioning allows you to have more performant queries. Let's say you have a data set for US Census data.
Yes.
We have 50 states. We can partition by state. Now we have 50 subdirectories. And let's say you want to write a query that just looks at Massachusetts and New York. Then you would just look at those subdirectories, just 2 instead of all of them, like with the table scan.
Yes.
Make sense?
Yes, you're right. Oh, I need to practice thinking about this.
That's what we're doing right now. So
Yeah, that's really good because I didn't really think about it at all. Yeah. Oh, that's right. Yes.
So generally speaking, if they ask in like an interview question, just say, it avoids table scans.
Yes.
So we have Impala, we have Hive. Do they work on the same tables in HDFS or different tables?
Yes, they can work in the same table.
What is the difference between a query run from Impala and one run from Hive?
One is faster, the one in Impala is faster.
Like, what are the steps for a Hive query versus an Impala query? Just high level.
High level. High level is the same.
Oh. Well, then again, it's kind of like, I'm not being too specific because high level does end up with the same. So I'll just say it. I was just going to say Hive has basically Hive will query the metadata every time. And Impala will just do it on the first time. And it caches it. That was it, basically.
Yes.
Okay, let's talk about databases now.
Mm-hmm.
What is a database?
Database is where you store data.
What unit of data does it store?
Uh, Units, bytes, logic
Logical grouping of what?
of data, like logical
What unit? Tables. Tables.
tables. Yes.
You know, it just helps keep things organized, clean, and it can facilitate access control,
Mm-hmm.
right? We can,
Yes.
okay. So what would you do if you had a table with some sensitive data in it, like credit card numbers,
Mm-hmm.
and then you have access to see that data because you have the necessary clearance, but you need your team to start analyzing that data, but you don't want them to see the credit card info? What would you do? What kind of data definition? Uh,
Hash it.
what's up?
I need to hash it, but to hide the files that is sensitive.
How would you hash it though? Like if you hash it, then you still need to be able to see those credit card numbers, but you don't want your team to see it. So what would you do?
Oh, shoes masking.
Then how would you see it?
Oh, I need to keep the key, right? So when I need to know the data, then I need to unmask it.
That can work, but there's something much simpler that's native to databases.
Oh, you need to give the user access to a certain table. So,
How would you do that?
oh, and
You don't want them to have access to your table.
you can, yes. So you can either give the user access, right, or you create a temp view where you like remove the data that's sensitive, so the user can access only the temp that without the sensitive data.
Yep, just a view. Essentially, it's just a constrained interface. Just create a view with the data except for the credit card numbers.
Yes.
Got it. In HDFS, where do the views get stored? I mean,
Oh,
like data. Where do they live? Where's the data file for the view?
in temp.
Where?
So in my workspace, they create a like a playground, which is where like the user can access the data in there and do the query and changes there. So in there, the table only select with no confidential data. So is that like how is it? So,
Let me rephrase that. You have your table A
mm-hmm.
in some path, and then you create a view from that table so
Yes.
that your other analysts can't see the credit
Mm-hmm.
card numbers associated with table A.
Mm-hmm.
So
Yes.
now your view is called view A. Where is that in
Mm-hmm.
the file system?
It's in the temp folder. Sorry, I don't know.
It's still technically in table A because all you're doing is just running a query. It's just saving the query essentially.
Oh,
It's kind of like a trick question.
oh, I see.
Like
Okay.
the data, like where's the data? It doesn't replicate the data. So the benefit of this is that it can actually save space because if you create a new table without that field, then you're just duplicating data. You're duplicating information.
Mm-hmm.
Necessarily, you're taking up space. So a view can be better in that case because it acts like a constrained interface. So they only see what you want them to see, and all they're doing is just running a query. That's all a
Mm-hmm.
view is. It's just a save query.
Oh, I see. Yes.
It's better for security too. That's the main reason.
Yes. All right.
So just in summary, some of the things that we talked about is
Mm-hmm.
Hive and Impala enable analysts to perform big data analysis without knowing how to
Mm-hmm.
program.
Mm-hmm.
both of them reference the metastore to gather data about a table before executing a query against it. But in the case of Impala, it will just do it the first time, and then after that, it caches that information. And Impala is faster than Hive, but Hive is more robust. It provides fault tolerance. Impala is fast because it runs directly against the cluster without the need for Spark or MapReduce to act middleman. Because of this, Impala is not fault tolerant. It doesn't have that functionality built in, but that's fine because even if a query fails, you run it and it's so much faster anyway that it will probably still finish faster. But remember, Impala is entirely memory based, so you have to be careful when you're dealing with a lot of data and a lot of joins because it holds all that data in memory. So it's kind of like a
yes. Oh, and how do you normally refresh the Impala Metastore? Like,
I'll show you. You see?
yes.
You go to the Impala editor, click this little thing, invalidate all metadata.
Oh, I
I'm
see.
sorry. I don't like using that. The way I would do it is invalidate metadata and then the table.
Oh, I see.
And then one thing that's really good to do is do compute stats. It computes some stats against the table that you just built. And then it stores that with the table. So basically, when you try to run a query against that, it can use the compute stats to optimize the query.
Oh, I see.
It would be even faster.
I see.
Yeah. So, what do you think of that? Like as a good, just
Really
a first
good.
intro?
It's really good, Smith. Do you want to me to prepare the content next time so we can take turn? We should go through with the course that you take on CCA.
Yeah. Okay.
Okay.
I don't mind. Like, okay, yeah, I'll probably need time to come up with more stuff.
Yeah, I think so
Last
too.
week was just terrible for me at work. Like, we had a whole bunch of our objectives due yesterday, and we finished 150% of them. But I overworked myself to the core to get everything done.
Wow.
So that's why afterwards, as soon as I finished, I was dead tired. I, I started drinking coffee again. It's very addictive, and it doesn't really seem to help. Went to my parents' house to go bring my father to get some food. Then I came back here, and I was just dead tired.
Yes. Oh, I see. Oh, am I still in your screen? Oh no. How do I escape?
Oh, let me
Yeah. Here,
stop.
yes. Oh,
There you go. You're free.
yeah.
Um,
Yes, I'm free.